here's a problem that, while very similar to example 4, it has a few extra kinks, so I thought I'd cover this one specifically. It starts out with Susie buying the same machine, except for the first 6 months. It earns money at kind of this weird rate, right? This 90 plus 20t. And then after that 6 months, she earns money at a rate, or the machine earns money at a rate of $100 per year. This is your interest. The first question is just say, well, look at the first year of profits from this machine. What is the present value of those profits? And so we kind of see that, well, the machine changes at 6 months, right? So we'd say the total present value, PV total, is going to be equal to the present value from first 6 plus the present value from the last 6 months. All right, and so what that means is like the first half of the year, the second half of the year. Now, this is going to be equal to some integrals, right? We're going to be using our Formula 1 here, and so it's going to be equal to the integral from 0, but not to 6. T has to be in years, so it's going to be equal to the integral from 0 to 0.5. And the income stream for those first those first half year is 90 plus 20t. Then it's e to the negative 0.05t dt. Now, this last formula is what's a little bit tricky. And part of the issue is we've kind of been thinking about this formula a little bit wrong. We shouldn't be thinking about it from 0 to our end time. We really should be thinking about it from our start time to our end time, from the beginning time to the final time. The beginning time of this present value is not 0. It's actually month 6, right? 6 months to 12 months. So this is really 0.5 on the bottom there. Up here, we will have 1. My present value is going to be, or not my present value, my income stream is 100, and then e to the negative 0.05t dt. Now, this is an expression up here that you could just type into your calculator, and you would end up with about $95.06. So poor Susie only earned $95.06 in the first year with this fancy machine she bought. So the question is, if that's as much as she earns after the first 6 months, how long does it actually take her to pay this thing off? When does the machine become worth it? And so we're going to use a very similar formula to what we used above. So notice that the machine cost $1,000. So we're basically saying, how long is it until we have this present value total being $1,000? So the right side is the left side is now 1,000, and the right side is going to stay largely the same, except we're not going over just to the first year. We're going as far as we need to, right? So this first term will stay the same. It'll be 0 to 0.5. The first 6 months stays the same. Plus 2t e to the negative 0.05t dt. But the last term is what changes. We don't go from 0.5 just to 1. We don't go just to the year. We go all the way out to whatever end time it takes for this quantity to not be equaling $95, but equal to 1,000, right? And so this, what's on the inside, is going to stay the same. And from here, we need to start to work things out. So the first thing that you can notice is that this term right here, this is something that you could do by hand separately or plug it into your calculator. Now, if you did that, you would get, you can subtract that over to the other side, and you would end up with about $953.10 about. So this thing itself is somewhere around 47 bucks, and then this is still equal to the integral from 0.5 to capital M of 100 e to the negative 0.05t dt. And from here, it's actually very similar to what we did when we solved example 6. The first thing we have to do is pull the 100 out and divide by it. So then we'll end up with 9.53099 is equal to the integral from 0.5 to capital M of e to the negative 0.05t dt. Now we actually need to do the integral, so we'll end up with 9.53099 is equal to, and this is e to the kt, so the integral is 1 over k e to the kt. And this is going to go from t equals capital M to t equals 0.5. So notice here, like if you had thought M was a number, pretend M is 10 or something like that. This is something that you could have plugged into your calculator using FNINT. Now, this is something that you do not use FNINT for anymore. You simply have this expression, you plug in m, you plug in 0.5, and you take the difference. And so I'm starting to run out of space, so I'm going to speed it along a little bit. I could make it even easier by multiplying, before I plug that stuff in, multiply by that negative 0.05 to get it on its own. Negative 0.05 times 9.53099 is going to be equal to just the e part of this expression. And so to actually get this, I'll have e to the negative 0.05 times capital M minus e to the negative 0.05 times 0.5. Now I'm going to add one more page in just so I can finish this off properly. But what I'm going to do is this thing is actually a number. This second part here is actually a number. So I'm going to add that over to the other side. So I'll have negative 0.05 times 9.53 whatever plus e to the negative 0.05 times 0.5. And from here, I would be taking ln's, right? Because this is just equal to e to the negative 0.05 times m. So taking an ln drops this thing down. So I really end up with the ln of what was on that side, 9.53 plus e to the negative 0.05 times 5. And then if I divide that ln by the negative 0.05 there, I will get my m out. So if you go and type this whole thing into your calculator, you will actually end up with m is equal to about 13.9126, which makes sense, right? If she's earning about somewhere around $100 a year, after about 13 years, you can expect that the present value of that income stream is in the range of the $1,000 that she used to start. So the big key here is just with this problem is kind of understanding the setup and then kind of realizing that this is a number, and so what you really have is some number equals this integral here. And from there, maybe if you're having trouble understanding the work from here, go back and take a look at example 4 and see if that helps.